Hi guys, today's topic is carbon compounds. In this topic we are going to see about carbon based compounds, their physical properties and chemical properties and their reactions with the other compounds. Most of the things in living structures are based carbon. For example, food, clothes, medicines. Many of the living structures is based upon a carbon compound. The examples are food, clothes, medicines, etc. So most of the living structures is based on carbon. The earth crust is containing 0.02% of carbon. Earth crust. And in atmosphere there is 0.03% of carbon dioxide is present in atmosphere. Earth crust contains 0.02% of carbon. It is not containing directly, it is containing in the form of carbonates, hydrogen carbonates, coal and petroleum. So it is not containing directly carbon, but it is containing in the form of minerals such as carbonates, hydrogen carbonates, coal and petroleum. Now we are going to see about bonding in carbon. The carbon bond is the covalent bond. Before that we have to know about what is meant by covalent bond. Sharing of electron pair, sharing of electron pair between two atoms, any two atoms, and that is known as covalent bond. Okay, in between, for example, here one atom is present and here another atom is present. This atom's electron and this atom's electron is going to share with each other. So that sharing of electron pair of two atoms is known as covalent bond. Okay, now before that we are going to see about some of the physical properties of the carbon. Generally the carbon is poor conductors and it is having low melting and boiling point. Why it is having low melting and boiling point means the bond between the carbon is strong, but the intermolecular force between the two atoms is not that much strong. It is little bit weak. So only it is a very poor conductor and it is having low melting point and low boiling point. For example, some of the carbon compounds, let me see. Carbon compounds. Example, acetic acid. What is the formula for acetic acid? CH3COOH. It is containing carbon here. It is an example of carbon compound. So this acetic acid, melting point in Kelvin and boiling point in Kelvin. Okay. So is the acetic acid melting point is 290 Kelvin and boiling point is 391. And next, another one example for carbon compound is chloroform. What is the formula for chloroform? CHCl3 and its melting point is 209 and boiling point is 334 Kelvin. And next one is ethanol. What is the molecular formula? What is the formula for ethanol? CH3OH. Okay. And its melting point is 156 and its boiling point is 351. Next one is methane. What is the formula for methane? CH4. 1 carbon and 4 hydrogen. See here, 1 carbon and 4 hydrogen is sharing their electrons. So there will be present a covalent bond. Here 90 melting point and 111 boiling point. Now we are going to see the electronic configuration for carbon and the covalent bond also. Atomic number of carbon is what? C6. So it is containing 6 electrons. Okay. first shell and second shell, K shell and L shell. In K shell it is containing 2 electrons, in L shell it is containing 4 electrons. So totally 2 plus 4, 6. So it is containing 6 protons. Now in the outermost shell, this is the outermost shell, okay. In this outermost shell, it is containing totally 4 electrons. If we add plus 2 electrons, totally what will come? 6. No, we will add 4 electrons here. Then it will come 8 electrons. Okay. Finally, in the outermost shell, it is containing 8 electrons, means it will get the noble gas configuration. I already told in the previous video and previous chapter, we saw about what is octet and what is noble gas configuration. In the outermost shell, if it is containing 8 electrons, means that is known as noble gas configuration, and then it is known as octet level, we said. So here carbon is containing in the last shell 4 electrons. If we add 4 electrons, it will become 8 electrons. It will get noble gas configuration. But if we are adding 4 electrons, means totally here 8 and here 2. You just imagine you are adding 4 electrons. So here 8 electrons will come, here already 2, so totally 10 electrons. It is difficult for carbon to contain 10 electrons in the nucleus. It is it is difficult to contain 10 protons in the nucleus. This is not for only carbon, for many elements this is the main problem. Otherwise, if we lose 4 electrons, so it is not capable for having 10 electrons. So if we lose 4 electrons, means what will happen, means a large amount of energy are required to remove 4 electrons. Again I will repeat, it is containing 4 electrons in the outermost shell. If we add 4 electrons, means totally it will come 8 electrons and it will get noble gas configuration. It will come to octet level. But carbon, it undergoes one problem, which is difficult to contain 10 electrons in the nucleus. Otherwise, if we remove 4 electrons, means large amount of energy required. So that is also difficult. So carbon undergoes this problem. Not only for carbon, many elements undergoes this problem. Now some simplest molecule formation by using the bond we are going to see. Molecule formation and the covalent bond we are going to see. Okay. A single bond we are going to see. First, what we will take means H2 molecule. Here hydrogen, 2 hydrogen, here 1 hydrogen, here 1 hydrogen. Hydrogen atomic number is what? 1. So it is containing how many electrons? 1 electron, and it is also 1 electron. So this 1 electron and this 1 electron going to share. So here one single bond is formed. How it means? I will draw one diagram. Here hydrogen atom, here hydrogen atom, and this atom containing here 1 electron, this hydrogen containing here 1 electron, and these 2 electrons is going to share. Okay, if it shares, means how the diagram will come. These 2 electrons shared. So the sharing of electron pair between 2 atoms, which is denoted by single bond, and this is known as covalent bond. This is H2 molecule formation. And next, oxygen, O2 molecule formation we are going to see. Okay, for this oxygen, 2 oxygen, here 1 oxygen, here 1 oxygen. Oxygen atomic number is 8. Okay, so K shell, L shell we know. In K shell it is containing 2 electrons, in L shell it is containing 6 electrons. If we have any doubt for the electronic configuration, means atomic structure about the atomic structure and electronic configuration, I gave the link in the description. You can see clearly about KLMN shell, how many electrons the shells will contain. Okay. Now, according to the electronic configuration rule, in K shell it is containing 2 and L shell it is containing 6, totally 8 electrons. The oxygen is containing 6 electrons in the last shell. In the last shell it is containing 6 electrons. To get octet, how many electrons it should be have? It should be have 8 electrons. For octet, it have to be contain 8 electrons. If we add here 2 electrons means automatically it will come 8 electrons. So I am going to add here 2 electrons. So from this oxygen 2 electrons, from this oxygen 2 electrons is going to share. Okay. So I am going to draw a diagram for oxygen in last shell. In last shell it is containing 6 electrons. So 1, 2, 3, 4, 5, 6. Another one oxygen 1, 2, 3, 4, 5, 6. Now these two is going to share the electrons. Okay. So the diagram will be here oxygen 1, 2, 3, 4 and the shared pair of electrons comes here. So the bond will be double bond. Okay. Now another one molecule, nitrogen, we are going to see. For nitrogen, atomic number is 7. Okay. Here N2 molecule we are going to form. So nitrogen 7 means K shell, L shell. In K shell it is containing 2 and in L shell 5. So totally 2 plus 5, 7. 7 electrons it is containing. To get octet, how many electrons it should be? For octet, 8 electron it should be. So if we add here 3 means totally 8 will come. So in nitrogen we are going to share 3 electrons. So here nitrogen in last shell 5 electrons it is containing now. So 1, 2, 3, 4, 5. Like that another nitrogen 1, 2, 3, 4, 5. So if we add 3 means we will get 8 electrons. So this 3 electron is going to share. So finally nitrogen 1, 2, 1, 2, 3 and this nitrogen 1, 2, 3, 1, 2. The 3 electrons are shared. So N triple bond N. Okay. Now methane formation. What is the formula for methane? CH4. So here 1 carbon and 4 hydrogen is going to join. 1 carbon and 4 hydrogen. So carbon, what is the atomic number? 6. We know in K shell it is containing 2 electron and in L shell it is containing 4 electron. To get octet we have to add 4 electron. Okay. So for carbon we are going to share 4 electrons. Here how many hydrogen? 4 hydrogen. So hydrogen atomic number is 1. So it is containing in its last shell, in its K shell it is containing only 1 electron. For hydrogen this is the last shell and it is containing only 1 electron. How many hydrogen we are taking here? 4 hydrogen. So from 4 hydrogen we are going to share 4 electrons. Okay. Carbon, it is containing 4 electrons in the last shell. We are going to share 4 electrons to get its octet plus hydrogen also. How many hydrogen? 4 hydrogen we are going to take here. This hydrogen and all containing 1 electron in its last shell. So this and all going to join. This and this. Okay. From carbon the 4 electron, from 4 hydrogen 1 electron. So totally the bond is look like this. So this is CH4 formation, methane formation. Methane is a compound of carbon widely used as the fuel and it is a major component. It is a major component of biogas and CNG. Okay. Thank you.